Section 310, three topics. Topic 1, derivatives of inverse trigonometry functions. Topic 2, inverse functions in general. Topic 3, the graph of function f and the graph of its inverse function. Topic 1, what is the inverse of a function? Here is the definition. Given a function f, if you can find another function g such that whenever f takes upon a to upon b, function g takes b back to a, then function g is called the inverse function of function f, and we denote g by this notation, f inverse. Please note that f inverse doesn't mean 1 over f of x. Here is a diagram to explain the definition. This line is the number line. Point A here, function f takes point A to point B. If function g is the inverse function of function f, then g should take b back to a. There are 6 inverse trigonometry functions: inverse sine, inverse cosine, inverse tangent, inverse cotangent, inverse secant, and inverse cosecant. Take inverse sine as an example. Sine of 30 degrees is 1/2. Then inverse sine takes 1/2 back to 30 degrees. Namely, inverse sine of 1/2 is 30 degrees. Please note that inverse sine is not equal to 1 over sine. A second and less confusing notation for inverse sine is asine. With implicit differentiation, one can obtain the following derivative formulas. Derivative of inverse sine is 1 over the square root of 1 minus x squared. The derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. The derivative of inverse tangent is 1 over 1 plus x squared, and so on. You just need to remember these 3 derivative formulas for inverse trigonometry functions. Here is one example about the derivative formulas of inverse trigonometry functions. Consider this function. This function is not a product, not cosine times inverse sine. This function is a composite function. Combine cosine and inverse sine together. Part A, find the derivative of this function. Part B, find the equation of the tangent line to the graph of function f at the point 0, 1. This point is on the graph of function f. Solution to part A. To find the derivative of this function, I need the chain rule. Take derivative on the function. then simplify the function. Let u below inverse sine of x. Then the function becomes cosine of u. To find this derivative, the derivative of cosine of u with respect to x, I need the chain rule. Insert du to the denominator and to the numerator. Then this derivative is the product of these two derivatives. Derivative of cosine of u with respect to u is negative sine of u. Now remove u. Plug in inverse sine of x in the u here. Then I have this equation. Now for this derivative of inverse sine by formula is 1 over the square root of 1 minus x squared. Then I have this equation. Please note that sine of inverse sine of x is x, because inverse sine takes x to somewhere, to a point somewhere. Sine takes the point back to x. So I have this equation. Now move x to the top, then I have this equation. This is the result of the derivative of function f. To help myself answer part B, I arbitrarily draw a curve. And suppose this curve is the graph of function f. Suppose the point 0, 1 is here. At this point, there is a tangent line, and we need to write down the equation of the tangent line. To write down the equation of the tangent line, we need to know the slope of the tangent line. In part A, we have compute derivative of the function. Now, to tell the slope of this tangent line, plug in 0, the x coordinate of this point, in the derivative. Then plug in 0 in the derivative, then we have 0. So the slope of this tangent line is 0. Now we can write down the equation of the tangent line by the point slope formula. Y minus y1, y1 is the y coordinate of this point, is equal to slope 0, parenthesis x minus x1. x1 is the x coordinate of this point. Simplify this equation, then y is equal to 1. The line is a horizontal line. This is the equation of the tangent line at the point 0, 1. Topic 2. Inverse functions in general. In the topic, I want to answer this question. Given a function, how to find its inverse? There are 3 steps to answer the question. Step 1, solve the equation y is equal to f of x for x. Step 2, interchange x and y. Step 3, replace y by f inverse to get the inverse function. Take a look at some examples about the 3 steps to find an inverse function. Example 1. Let function f be this quotient. Part A, find the inverse function. Part B, find the derivative of the inverse function. Solution to part A. Step 1. Solve the equation y is equal to f of x for x. Now in this example, this equation is this equation. Solve this equation for x. Move the denominator to the left side, then I have this equation. Distribute y to x and to 2, then I have this equation. Move x to the left side and 2y to the right side, then I have this equation. Factor out x on the left side, I have this equation. Move the factor y minus 1 to the right side, I have this equation. Take out the minus sign on the top, then I have this equation. Step 2. Interchange x and y in this equation. Then I have this equation. Step 3. Replace y, the y here, with f inverse. Then this is the answer to part A. We can have a check whether or not the answer is correct. Arbitrarily pick a point, say 1, and evaluate the function value at 1, then I get negative 2 over 3. Namely, function f takes the point 1 to negative 2 over 3. If the answer is correct, f inverse should take negative 2 over 3 back to 1. Now have a check. Plug in negative 2 over 3 in the x here, then I have this equation. 2 times negative 2 over 3 is negative 4 over 3. Negative 2 over 3 minus 1 is negative 5 over 3. 3 minus 4 over 3 is 5 over 3. And this quotient is 1. Therefore, my answer to part A is correct. Part B. Now we have the inverse function. Find the derivative of the inverse function. Take derivative on the inverse function. Then I have this equation. By the quotient rule, this derivative is equal to derivative on the top times the bottom minus the top times the derivative of the bottom. Then all divided by the bottom square. 3 plus 2x derivative is 2. X minus 1 derivative is 1. This is the answer to part B. This example doesn't require us to simplify our answer. Example 2. Let f be x squared. Find the inverse function. Solution. Step 1. Solve this equation for x. In this example, this equation is y is equal to x squared. Take square root on the both sides, then I have x is square root of y or negative square root of y. Step 2. Interchange x and y in this equation. Then I have this equation. Step 3. Replace y, the y here, with f inverse. Then I have 2 inverse functions. Since function f has two inverse functions, function f has no inverse due to the following convention. Convention: when a function has more than one inverse function, we say that the function has no inverse function. This is similar to limits. When a function has more than one limit, we say that the function has no limit. Here is a remark about this example. The function in the example is a 2-to-1 function. For example, the function takes the point -2 to 4 and also take the point 2 to 4. Graphically, the function takes this point and this point to one point, to the same point. So I say that the function in the example is a 2-to-1 function. For a 2-to-1 function, the function must have two inverse functions. Therefore, by this convention, the function has no inverse. Topic 3, the graph of a function and the graph of its inverse function. Plot the graph of function f, and plot the graph of f inverse. Then draw a line through the origin with slope 1. Then it can be seen that the graph of f inverse is a reflection of the graph of function f in this line. Also, the graph of function f is a reflection of the graph of f inverse in the same line. Now, pick a point, say x0, y0 on the graph of function f. And at the point, draw a tangent line. Then the slope of the tangent line is derivative of this function evaluate at the x coordinate of this point. Namely, the slope is f pi of x0. If we reflect this point in this line, then we will have a point on the graph of f inverse. The x and y coordinates of this point are y0, x0. At this point, draw a tangent line. Then the slope of this tangent line is derivative of this function. Evaluate at the x coordinate of this point. Namely, the slope of this tangent line is derivative of f inverse at y0. It turns out that the slope of this line and the slope of this line are closely related. The slope of this line is a reciprocal of the slope of this line and vice versa, namely these two equations. This is the slope of this line, and this the derivative of f inverse evaluate at y0 is the slope of this line. In the following, I show you two examples about how to use these two formulas to solve problems. Example 1. Find the derivative of the inverse function of the following function f at the specific point on the graph of f inverse. 5,2. This is a point on the graph of f inverse. The function f is x squared plus 1, where x is non-negative. About this example, there are two solutions. In solution 1, I explicitly find f inverse. After I get f inverse, I compute the derivative of f inverse at 5. In solution 2, I use this formula. Now, solution 1. To find the inverse function, step 1, solve this equation for x. Move 1 to the left side, then take square root. Then we have x is positive or negative, square root of y minus 1. Because x is non-negative, we reject the solution negative, square root of y minus 1, and only keep this solution. Step 2, switch x and y in this equation. Then we have this equation. Step 3, replace y, the y here, by f inverse. Then we have the inverse function is square root of x minus 1. After we get the inverse function, we compute derivative of the inverse function at 5. Take derivative on the inverse function. To compute the derivative of square root of x minus 1, we have to use the chain rule. Let u below x minus 1. Then this function becomes square root of u. To compute derivative of square root of u with respect to x, we need the chain rule. By the chain rule, write this derivative as this derivative times this derivative. Derivative of square root of u with respect to u is 1 over 2 times square root of u. Now, delete u. Plug in x minus 1 in the u here. Then I have this equation. Derivative of x minus 1 with respect to x is 1. This is 1. So this is the derivative of the inverse function at x. Now, plug in 5 in x. Then we get derivative of the inverse function at 5 is 1/4. Solution 2. In this solution, I want to use this formula. By this formula, the derivative of f inverse at 5 is equal to 1 over the derivative of f at 2. Function f is x squared plus 1. Derivative of x squared plus 1 is 2x. Derivative of x squared plus 1 is 2x. Then plug in 2 in x. Derivative of f at 2 is therefore 4. This number is 4. Therefore, derivative of f inverse at 5 is equal to 1/4. Example 2. Suppose the slope of the curve of the inverse function at a point 4, 7 is 4/5. Find the derivative of f at 7. Suppose this curve is the graph of the inverse function. The point 4, 7 is here. At this point, there is a tangent line. The slope of the tangent line is the derivative of this function at the point 4. The slope of the tangent line is given to be 4/5. Therefore, this derivative is 4/5. Now, using this formula, derivative of f at 7 is equal to 1 over the derivative of f inverse at 4. The derivative of f inverse at 4 is 4/5. Therefore, derivative of f at 7 is 1/4/5. It is 5/4.